Hi everyone, today we are going to solve LeetCode 102, which is called binary tree level order traversal. So given a binary tree, return the level order traversal of its nodes values. So let's see. The level order basically says that just print the first level, then everything on the second level, then everything on the third level, etc. So apparently they want us to return a list of lists or a vector of vectors in this case. So what are we going to do? So in this case, the idea is very simple actually. We are just going to use BFS, breadth first search, or breadth first traversal as you wish. So what we are going to do is we are just going to start from the root. If we have a left child, we are just going to go to left child. And if we have a right child, we are going to go to right child. But we have to keep track of levels, right? So what we can do is basically we can just keep a list of lists, and for each level we are just going to keep a list, and we just need to keep the level of each node. So let's just start coding and we will talk through it. So let's say we do not have root, then what we are going to do is we are just going to return an empty vector, right? So if we are not here, we have passed this case, then we have a root, so we are just going to start coding. So let me just create the answer array, and which is going to be another vector here. So actually what I can do is I can just create an array of vectors. Let's call that levels and values, right? And let's say it has 100,000 like levels. So this will basically keep the elements on level I. So what will keep that? Let me show you. So levels and values I is going to keep all the elements on that level. That is what I'm going to make sure of. So let's start writing the BFS code. So we need a queue apparently, and in this queue we will apparently need some tree nodes, but we will also need to keep track of the level. So what I'm going to do is I'm going to keep a pair, and this pair will have tree node and an integer which is going to represent the level. So let's call this queue, and what I'm going to do is I'm going to push this queue the first thing I have. So I will make a pair out of them. The thing is I will send root, and I will just send 1 as the level of the root, okay? And what I'm going to do is I'm going to check if this queue is empty or not. It should not be empty, right? So if it is empty, I'm done. What I'm going to do is I'm going to take the tree node, the first node at top, and I'm going to check if this has a left child or a right child, etc. So let's create a tree node pointer here, and let's call that current, which is going to be q.front.first, because qFront is going to return me a pair, the first of which has a tree node, right? Like here. So the first one is going to be the current node, and the second one is going to return me an integer, which is going to be the level. So which is going to be, which is going to look like this. And then I am going to just pop this thing away. So I'm going to get rid of this. And right now what I'm going to do is I'm going to check if the thing has a left child. So current left exists. If the left one exists, then I'm going to do this. I'm going to push the left one and level +1, because that is a child of this level. So it's like I am here, and when I have a left child and I have level 2 here, this is going to have level 3. So what I'm going to do is I'm going to make a pair of current left and level plus 1. This is what I'm going to do. And also I will do the same thing for the right hand side. So here I'm going to send level plus 1. So this is the case, and this is almost done. So what I'm going to do is I'm going to update this array here. So I will have to update the level of this array, right? So let me write it. Levels and values, level pushback. What I'm going to push here is an integer, which is the value of this current thing, because I know the level of that current node, and I'm just keeping track of all of these. So current.value is going to be pushed right over here. At the end, what I will have is a list and everything on those levels, right? So what I'm going to do is I'm going to create a vector of vectors, which is going to be basically answer over here. And I'm going to start from level 1 because that is where my root is. So actually let me call this level 1. Level is smaller than, like, let's not put anything here. I will handle it later. So I will start from level 1 and I will increase levels until where I find a level which has no nodes in it. So let's push everything. Let's push back levels and values level, right? Everything on that level should be a list for this thing over here. And I'm going to check if this has, let's put it actually here. If this has 0 size, which means there is no node on this level over here, then I'm going to just break. Okay, and I will update answer later, then I will just return answer. So let's see if this works, and we will go through the complexity, etc. So it works on this case. So can we change like things a little bit? Okay, it works here too. Let us submit the code, and then we will talk about the complexity. So it works. So let's talk about the complexity. So we keep track of each level, and this is going to, space is very large over here because we do not know the upper limit of the number of nodes. We cannot put anything here. We could make it a little bit different using like a hash map or so, but we do not need to do that in this case. So we have, let's say, n nodes. What we do here is taking O(n) step, because this is simple BFS. And after this, because we are just keeping things, taking things from one list to another, so it also takes O(n) time, so the solution takes O(n) time overall. And it takes overall O(n) space because this place will at most keep n nodes, right? So thank you very much for watching.